Welcome back everyone. My name is Sagar and in this video we will be learning about encapsulation in Java. So it is the fourth main pillar of OOPS and let us see what it is. So what do you understand by the word encapsulation? So here you can see. So here the main word is capsule. So what is a capsule? Capsule is something that contains medicine and it also have a covering, right? So encapsulation means that it is the process of capsuling something, right? So it is the simplest definition. And in our programming, encapsulation means that we are just wrapping up all the things inside of a class. So our class is just like a capsule and we are just implementing everything inside of a class. Okay, so the best example is of a car. So suppose there is a car, how it is similar to a capsule. So capsule means that we have inside something but we don't care about that, right? We just have the covering and we just have to eat that thing, we just have to consume that. So in the example of a car, we just have the engine of the car and we don't have to work directly with the engine. We just have to start the car and we just have to move. So we just have to use the car, right? We don't have to need the implementation. We don't need to know about the internal working of the car. We just have to enter our key and we just have to start our car. And that's not your task to just start your engine and fuel your engine. So let us just create a class here. Class car. So if you are following our course, then definitely you will not get confused in abstract classes and encapsulation. So abstraction is different thing and encapsulation is a whole different thing. We are going to also talk about that. So if you are defining a general car, then that should be an abstract class. And if you are watching this video after our abstract video, then you know the difference, how this car is a general thing and why it should be abstract here. But here we are learning about encapsulation. So here we are defining a car. That means there is some car. So let me define a general car. Suppose it is a race car. So we are defining a race car and that is a particular thing now. Okay, so it should extend our car and that car will be our abstract class. Okay, so that is not an issue and I think it was in our lecture 31. So you can check out our lecture 31 if you want to learn about our abstract classes. So it is here a race car class, and how can we just encapsulate all the things inside of a race car? So suppose there is an engine. So suppose I am defining an engine and this is a string value. So if we are not implementing this thing with encapsulation, then that means when we are creating a race car object, race car, and here new object of race car, then here we are not using the encapsulation property. So what we can do is we can just directly access this engine and race car dot engine equal to, suppose I am writing here my engine. So I am just defining here a custom engine. Okay, and after that I can also use this thing. Okay, semicolon here, and I can just print here race car dot engine. So what I am doing here, so first of all I am creating a race car object and then I am defining the engine, and after that I can also access it and I can also do this thing again. So race car, and here I am defining some new engine, and after that I am again printing it. So now it is a very simple thing. First of all, this is my engine and after that this is my new engine. So let me just check. But here I am not defining implementation of encapsulation. I am not encapsulating this thing, but instead I have to just directly access the engine, and there is nothing like putting a key and starting the engine. So you can see my engine and some new engine. So suppose now we have to encapsulate this engine thing. So what I should do, I will make it a private property. So private engine, and that means you know about private access modifier, that outside of this class now I cannot access any private thing, and now you can see there are errors now. So how can we do this thing? How can we update our engine and how can we just get our engine? So there is a very cool thing in Java that is called getter and setters. So let me just alt and insert here. So here you can see getter, setters, getter and setters, and I'm going to press OK. So here you can see get engine method and set engine method. This is a very simple thing. There is a get method using which I can just return my private engine value, and there is also a set method using which I can just set the value of this engine variable. So instead of here doing this thing, I can just define here. So here I have to define a new engine. So what I will use, set engine, and I'm going to use this thing here. So set engine, and here I have to get it. So dot get engine, and again here set, and here get. So this is the exact same thing, but it is more complex than the previous thing, because previously we are just directly accessing this engine and now I am just making all the things complex. No, I am not making the things complex, I am making it much easier and much secure. So here you can see output is the same, but how this thing implementing this getters and setter is more secure than just making it public. So this thing is more secure because now we are accessing this engine variable using only these methods, and I can just define some property or some security levels inside of these methods, and I just cannot do that directly from my variable. So that's why I have to use this method, and let me just show you. So suppose we are not changing this getter method, and using this I am just directly accessing this engine. But when I'm setting the engine, suppose I have to do it only one time. So what I will do is I will just write here a condition: if engine is equal to null. So that means if the engine is not defined currently, only then I will define it. So if engine is null, then only you can define it. And okay, I have to write here this dot engine. So if the value of this car's engine is null, so this dot engine means we already learnt about this keyword, and that means we are accessing the object of this current class. So that means this engine. So if this engine is null, only then we are defining our new engine, and that means both the times we are going to print my engine. Okay. So first time I am setting my engine, and currently you can see there is no engine implementation, and that means the engine will be this. And after that I am printing it, and after that I am again updating it, but it will not get updated. So that means I can only set my engine once when I am creating the object. So both the times I will just print my engine. So you can see this time I am doing this thing, and suppose I have to now access some key. So if I am defining some key here, so let me just create here another value, another member private string key. So key means the key for this car. Okay, so let me just create here not this engine, and I am just defining here key. So first of all, suppose I am defining here race car dot let me also define here set method for key will be public. I have to set a thing, so it will just return me nothing, and void set key, and you have to follow this convention. I already told you about this convention thing in our function video. So after that, this dot key will be equal to this key, and I also have to define it once. So I will just use the same condition: if this dot key equal to key. Okay, I have to define here a parameter string key, and now I can do this. I have to write here null. If this dot key is null, then I have to specify it, and else what I have to do, I have to just throw an exception. So you can just throw exception here, and we are also going to learn about exception handling. So only one time I can define our key, and let me just define it. So set key, and the key will be suppose xyz. So this is my key, and when I am starting the engine, so suppose I am doing here some another things here, and after a lot of time I am just defining race car dot start engine, or we can say set engine. So suppose if we have to set an engine, I have to also pass a key. So let me also pass here a variable, pass here a parameter string key, and now I have to confirm that if I am passing the same key or not, and let me just check here, and if this dot key will be equal to is not equal to null, so this is our check that previously we must define a key, and this value will be not equal to null, and this dot key equal to key, and this is a string. So you already know that we cannot compare string with using this double equals to method. We have to use here dot equals to method. Okay, so now this thing is clear. Let me use this in another line. So now you can see we are defining here these three things. That first of all, we don't have to define multiple engines. We have to define it only once, and that means if the previous engine is null, then only we will check. And after that, we have this logical AND operator, and after that we are saying that a key must be defined previously. Okay, so we are also defining here a key previously, and after that the key previously defined should be equal to the current key. So these are the three conditions that we are defining, and only after that we can set an engine. So we are just hiding everything, hiding this all logic from our user, and our user is just creating a car. So a race car, and after that we are setting a key, and we are setting an engine. So suppose I am setting an engine else. So suppose if any of these conditions are false, then we are going to print here wrong input. or you can just define here anything, that if this condition is null, then you have to say something else. If this condition is null, then you have to say something else. And if this is null, if this is false, then you have to say that this key is, that the pass key is not equal to the previous one. So first of all, I have to define here engine. So suppose I am defining here engine, and okay, the spelling is wrong. And after that, I have to define here key now. So what will be the value of key? So previously the value of key was xyz, and let me just define it xyz. And after that, let me try to access this engine. So race car dot engine, get engine. So if this key is the same as previous one, then we are gonna get this engine here. And if the key is not same, then we are gonna print this thing, and our engine value will be equal to null because we are never setting it here. So this time the key is same, and we are gonna just get our engine. So here we are getting our engine, and if we are passing here some another key xyza, then we are gonna get engine as null, and we are also gonna print this thing, wrong input. Okay, now you can see this thing, that we are just defining a high level of security here, and that thing is very cool. We just created a whole Java program to create a car and to set the engine of that car. And here we are defining private things. So if we are defining some private thing inside of a class, then that means we are using here data hiding. So data hiding is just a part of encapsulation, and you don't have to confuse in this thing. If we are defining a private member, then that is data hiding. And if we are accessing those private member using the setters and getters, then that means this is a part of encapsulation, because it is an implementation level problem. We are the developers, and we have to define how we are going to access anything inside of a race car. We are just writing a race car class, okay, and inside that, this is our task, this is our implementation task, that we have to define these things as private, and we have to define here getters and setters. You just can avoid all of these things, and you can just make your class simple like this, but that thing is not recommended. You just have to do this, and this is an implementation level problem, so you have to remember this. Encapsulation is implementation level. And what about abstraction? So if you are confused about abstraction and encapsulation, then remember to watch our lecture 31, and inside this we are defining this abstract class. And after this video, we also learned about interfaces. So both of these, abstract class and interfaces, are a part of abstraction. And you can see, when we are defining our abstract class, first of all we are defining a base class, and after that we are just extending our children classes with this base class. So inside this, you can also see we are using the inheritance, and also you can see we can just ignore this thing, and we can define it. It is a rectangle shape and it is a circle shape, and we don't have to override this thing. So we have to use all these oops concept to make our code much cleaner. So here, first of all, we have to define an abstract class that will be our base class. So what is the use of this? So abstraction is a design level problem, because here we have to design all the things, that there will be a base class that we cannot use to create objects, and all the children classes should extend this base class, that will be abstract class. And this abstract class will have abstract method and also concrete method. So abstraction is a design level problem, solves design level problem. If we are defining abstraction and we are using abstract class or interface, then we are solving design level problems. And if we are using encapsulation, then inside of a class, then we are solving our implementation level problem. And you can see how we are implementing our car. Okay, I hope now you understand all of these things, and thank you for watching this video.